not to scale, because this part happens very quickly, and so I would actually expect it to be, so Q is 0, so it would start here at 0. It's going to peak very quickly, that should be parabolic, and then not come back down. That's really not much better. Maybe.
Yeah, could you do question 5, from the, I think it's 2060 it says 5 electrons and 7 protons are moving to the right, on a piece of wire. And then 3 protons and some number of electrons are moving to the left, through the same piece of wire.
All right, like in the master set.
Yeah.
I mean, for the most part, people were almost there. Some people forgot some stuff. All right, so I gave you the current flowing across a certain spot at, I think it was 9 nanoamps in the master set.
Yep.
So I want to make this 5 nanoamperes. And I gave you the number of protons, I believe.
This one.
So in this one, you gave 5 electrons and 7 protons.
Oh, sorry, it's a different problem.
Yeah, we don't have any
All right.
number for the amperes.
So 5 electrons going to the right,
Yeah, to the right.
5 electrons and 7 protons going to the right.
okay?
And then to the left, there's 3 protons, and it says N electrons.
In electrons.
Yeah.
And
What is the equation for I as measured moving to the right in terms of N?
I need to see the
Yeah. It's this one here.
so 5 electrons, 7 protons moving to the right, there would be some wire each second. Protons and electrons travel to the left. What's the equation for I? Okay, in amperes. It's measured moving to the right in terms of N. Okay, so I know I need to figure out what is the charge passing by this particular spot, the charge per unit time. I've given the number of charges that I know are passing by second. And so my current would be, well, I have current flowing that way, so that amounts to, a current flowing that way means that I have, since I only have protons and electrons here, this would equate to a proton moving this way or an electron moving that way. Both of those would produce a current going to the right. So this 5 electrons going to the right is basically degrading it. I mean, so I have 7 positive charges going to the right. This 5 electrons going to the right, it's like having -5, because I need an electron to go to the left in order to produce current going to the right. 3 protons going this way also gets rid of them. And then I have N going to the left, N electrons going to the left, so that would plus N. So my current, since these are the number that pass per second, I have -5 plus 7 minus 3 plus N charges, sorry, yeah, base charge, E. And each of these is particles per second. And this, I need charge, I need number of yeah, that's particles per second, I need charge per particle. That ends up being -1, so I have N minus 1 times the base charge would be the current. So N minus 1 times 1.6 times 10 to the -19 coulombs.
And that's where you plug in if N is equal to 1, then it's equal to 0?
Yeah.
Okay. Yeah, makes sense.
Oh, so
Well, the
No,
answer
that's
is the
not.
equation.
The
Oh,
clue there was
yeah.
that, what would you need to do, and just as a quick check,
Okay.
if I had one electron going to the left, I should have zero current. That works given my formula here. You look like you're about to ask a follow-up question.
What is the equation that you're using in general? Like, it's charge times.
I'm looking at the
number-
amount of charge that passes per unit time.
Yeah,
I give in the problem, I have 5 electrons going to the right per second. I have 7 protons going to the right per second. So each of these is a particle per second.
okay.
So the per second is already built in. So-
Okay, yeah, it's not just the particle, it's particle per second.
Yeah, so this would have units of per second. So we end up with coulombs per second, which would give us amperes.
So so protons moving to the right are positive, and the electrons moving to the left are positive,
Yes,
and so if an electron moves to the right, it's gonna be negative,
yes,
and a proton moving to the left will be negative.
yes,
Is that why you redrew them on the side?
yes.
It could be opposite though, if we orient it.
Yeah.
We could be putting protons to the left, right? It's just because the problem said.
Well, the problem stated which way that they were going, as well as defining the current meaning to the right. 1 minus n is not the correct solution. But it's also, most of it's there. I'd probably take all 3 points. That's it.
Also, like, this is a dumb question, but for the bonus questions
Right.
on this one, you said, for the first question, you said like, so there's middle of nowhere, Beethoven's Fifth, end of March. And the thing you had in common with all of them is that they all have H in them. But then the second question, there was like some more complex.
All right, so fifth, you see why H, not just they're in common, but H is the 5th letter of March, that's the 5th of March. It's the, 5th of Beethoven, or whatever letter H falls into, and then the middle of whatever that other one was.
Oh, my God.
That's true.
Yeah.
So,
It's the fourth letter of middle of nowhere.
yeah, the middle of nowhere, the word nowhere, is
Yeah.
the letter H.
Yeah.
Oh, middle of nowhere.
No, I see that, like they all have
Okay.
H in them, but then you could say the same argument for the second one, where they all have an N in them.
No, I'm not just saying that they all have H in it, it's that I'm telling you where the H is in each of them.
Yeah, but in the middle of nowhere is the fourth letter.
Which is the 4th of 7 letters, the middle of the 7 letters.
Nowhere 7 letters, yeah. The middle letter.
Middle of
The middle
nowhere.
letter.
It's not the 5th letter in every one, it's where the H is located in each one of these.
Oh, yes. H is the middle of the word nowhere. The 5th letter of Beethoven is H. H is the end of the word March.
Oh, I said end of March, not 5th of March?
Yeah,
Okay.
but it's the 5th letter in March.
They also have, yeah. So the 5th of March and the end of March are the same.
Oh.
Which could pose a riddle that you can then tantalize family with, where is the end of March and the 5th of March the same?
Problem is, by the time we're done with the test, there's like no more brain power to figure out.
Yeah, I mean, it's,
We should do those first.
First.
But like, say they all have like a similar letter in common, we can't just say that,
no,
because that's a obvious.
yeah.
Okay.
As well as some people will write a story which has all the words in it, that doesn't get anything either. Or rarely does.
Oh, dang.
I did it.
Are you okay continuing to do problems, or do you need to start new material?
No, we can do problems. Go,
So,
Time's up.
this one, problem is, it's the circuit. It's this one, I trouble with part C.
Light bulb, okay, so let's see, R5 is the light bulb described instead of R2, so basically that's the light bulb, maximum voltage, so still 1.5 amps. Okay. I'm gonna draw something similar.
Yeah, like, or just that problem in general, like, where you're replacing a light bulb instead of and figuring out what makes it glow or whatever.
Something like that.
Yeah, something like, yeah. There was like 2 resistors on top of it.
Oh, okay. So, 1, 2, 3, 4, and 5. All right, so the first part, I know that was not the issue for you, but the first part was, I have a maximum amount of current that can go through a bulb before it blows. So if that is a light bulb right there, and I have a maximum current of 1.5 amps that can go through there, well, I know that whatever current's flowing through here has to be the same current flowing out of the power supply. And I know that the voltage of the power supply is equal to the current coming out of the power supply times my equivalent resistance. So if I find my equivalent resistance, all right, and then plug in 1.5 amps for I can find my maximum voltage. For part C, I change that, and I say, well, let's say that this is the bulb instead, and I have a maximum of 1.5 amps flowing off that. Well, I need to figure out the voltage here. I know the current flowing across here, and I know the voltage. Oh, sorry, and I know the resistance. So from here to here is 7.5 volts. Ohm's law, I times R. So it's 7.5 volts across the 4 ohm also, because they're in parallel. So if that's the case, then I know that 7.5 volts is equal to I times 4 ohms. So I can now find the current flowing across here. I know this is at 1.5 amps, this is gonna be whatever, 7.5 fourths, whatever that is.
So you kind of current for the right one?
Yeah. What is it?
1.875.
1.875? So, amperes. So at this junction, I have 1.5 amperes flowing down there, because that's a maximum, which forces this maximum to be 1.875 amperes, which means the current I have flowing into it is the sum of those two,
Why is the one on the left the maximum?
because that's the maximum. This is the maximum voltage, if that's the maximum current.
I don't get it.
If this is set to 1 volt, I'm not gonna get 1.5 amps flowing through this, I'm not gonna get 1.875 amps through that. As I crank up the voltage, I'm gonna get more and more current flowing through here until this blows. And this is gonna blow when I'm at that level.
Oh, and so it's all based on the resistance though, like, the same amount of current is flowing through each one, is the voltage is different, because the resistors are different resistance.
The way you set it, I know the voltages are the same for these two. The current is different.
Why is the current different?
Because there's a junction there. The current splits.
Yeah.
More current should be flowing across the path with less resistance.
Okay, yeah.
So once I establish this, if this is at 1.5 amps, this has to be at 1.875 amps, which means the total current flowing in has to equal the current flowing out of the junction. So the sum of those two becomes 3.375 amperes. That's the current flowing into the junction, which, because there's no other junction there, it also has to be the current flowing out of the power supply. So now if I take that times the equivalent resistance, which we found in part A, we have the maximum voltage of the power supply.
Oh.
Just we went with finding the one with the least
To find this one,
Yeah.
I went for the one that was actually in the problem, that I said, instead of making R5 have a maximum current of 1.5 amps. The limiting factor was given in the problem.
Dr. Fox?
Yes?
We've been pulling questions from, summer of 2020.
Right?
That was the test of doom and despair, apparently.
It was.
Yeah, I mean, it just keeps going. On our test, do you believe that we will have the same, like, 10 kind of questions and then the long answer?
That was the longest one out of all the other.
Yeah, the online classes had longer tests and harder problems.
Why?
Because
They had resources that they could use.
Oh,
On the
yeah.
plus side, if you really understand 2020, then maybe the test will be easy.
So there's maybe like 5, 6, like last test, 5 or 6.
Yeah, if you wanna know how long they are, look at not the pandemic ones,
Okay.
Oh,
at least the online
And I'm
pandemic.
guessing there's gonna be at least one, like we had on the quiz, where you gotta find and resist the current, and you do like the rule.
Oh, yeah, there's gonna be guaranteed, the last problem will be, what is the current across each resistors, what is the potential difference across?
It's not gonna be like the quiz where it was 3 and 4, it might be like 4 and 5. 4,
Total problems.
no, like on that same problem, we had 4 resistors, 3.
Oh, it will be, the only thing that'll be different are the numbers will potentially be different and the batteries could be flipped.
But it'll still be like 4 and 3.
Yes.
That's the problem, just like 5 of them, there's just
Yeah.
a lot.
It'll look very, very similar, same number of resistors, same number of batteries.
It's not, okay.
And for you future electrical engineers, it's a really stupid design,
For which one?
basically the quiz.
Oh, yeah.
When you're finding the current across the middle resistor, like we did in the Comer quiz, and
Right.
how do you go about doing that when you have batteries on the left and the right? Cause you have a current going up and then you have a current going down.
Then it's, well, if I've got 2 amps going this way and 4 amps going, or, so 2 amps this way and 5 amps this way,
Yeah,
well, the net result is 3 down.
3 down, cause
Yeah.
it's just a total.
Yeah, you just add them together.
Okay.
Technically, they're not vectors, but you kind of add them like vectors.
Like, I was looking at the homework quiz from the 29th that we did,
Okay.
and
Yeah, my memory is that you solved it 2 different ways. And,
yeah, the first way I did, I did it again because I had no time, and I was like, I think the second way was better, but then I redid it last night, and I got a different way. Yeah.
yeah, it also, and you did switch the direction of your current? Yeah.
I know.
Yeah.
But this one adds, like, so for the homework quiz, it had the 7 ohms in the middle,
Right?
and then on the left was like 15 volts battery, and then the right had a 9-volt battery.
Okay.
And I was trying to figure out the current going through it.
The actual current or just the direction of current?
Both. They both kind of confuse me. I got it right here, or a picture of it.
So I got 15 going up on the left and 9 going down on the right and 36 going down in the middle.
Yes.
All right, so I sort of picture them, when I'm trying to figure out the directions, if I wanted to not get a negative current, I sort of picture them like pumps. And they're, the higher the value, the more powerful the pump is. So if I had, I think it was 36 in the middle.
Yep.
And on the left-hand side was 15 up.
Yep.
And the right-hand side was 9
It's down.
down. So it'd be a 9, not a Q. and then connect. Well, obviously, that's the most powerful one. So even if you add those together, even if those were in the same direction, if you add them together, I'm not gonna get, it's not gonna overpower that. So this is just the way I'm thinking about it. So I would expect the current to be going down that way. If I picture this as water, current's flowing down like this, and it's gonna get pushed up from those two directions. So I'm gonna have, so I would expect the current water to flow like that. Now this one, I got water being shot down and going in both directions. Here, this is sort of helping the water flow. This, I got something fighting against it. I suspect that the current's gonna flow that way. But I do not, I could very well be wrong with that one. But that's the way I'm thinking through it. So I guess one question is, did I even address part of what you were asking?
For the process 7 ohm resistor, well, how do you find the current? Like, say, so you found the currents for I1 and I2.
Okay, doing mesh analysis,
Yeah.
so you found, so you, instead of doing current per path, you did basically a current here.
Yeah.
And a current here.
Yeah.
So I made it both clockwise. I don't know if you can't remember if you did or not.
Yeah.
So in the middle section here, I have A going down and B going up. A going that way, and I have B going that way. If I think of them like vectors, adding vectors, so if this is 3 and 5, well, if I choose that to be the positive direction, then I get 5 minus 3 or 2. It's positive, it's going up. If I have negative 3 and 5, well, I can still do it the same way. It's B minus A, thinking of what's